Welcome to our probability class, where we're going to learn the axioms of probability and how probability can be applied and spread, and also our questions to do with probability are attempted. So to begin with, what is probability? Probability, anyone in your own terms, how do you understand probability? Is probability applicable? Or just quickly, probability is simply the likelihood that an event will occur. It's a mathematical concept or statistical concept that quantifies the likelihood of an event. So this model is used to determine uncertainty or randomness in fields of engineering, economics, and more. Probability is always within a range of 0 and 1, where 0 represents an impossible event and 1 a most certain event. So there are two types of probability. We have classical probability, which is also known as theoretical probability, and we also have empirical probability, which is also known as experimental probability. Additionally, there's also what is called subjective probability, which we may not talk about so much. It's based on beliefs and opinions. But to start with, classical probability is one which we will look at when dealing with the coins, cards. It's type of probability where all possible outcomes in an experiment are equally likely to be associated with the chance. So it's usually calculated by dividing the number of favorable outcomes by the total possible outcomes. For instance, if you're rolling a die, which is 6-sided, the probability of getting one side is what? 1 out of 6. We also have what is called empirical probability, which is based on observations and examinations. So this is where we collect data and actual events and experiments. So we're going to look at conditional probability and its axioms later on. So it's very important that you need to understand that probability is applicable in our day-to-day lives. Did you know that you could predetermine the gender of your child by understanding probability so well? You could determine the likelihood of the success of an operation by understanding probability. There's a lot of damage that has been caused in the health fraternity and the deaths that were incurred for our beloved ones by doctors who've been unable to do their statistics very well because of wrong assumptions. Empirical probability is based on observed data, like I mentioned, which involves collecting data from actual events. For instance, tossing a coin and repeatedly tossing it and recording the results so that you calculate the probability of getting ahead. Subjective probability is a type where you base your probability on personal judgment. For instance, predicting a certain political candidate winning an election. You want to know the opinions of people, then you ascertain who has a likely win. There's conditional probability we're now going to look at of having an event occurring provided the other has already occurred. That is what we call conditional probability. So there are axioms of probability that you now need to know. So axioms or properties of probability, number 1 is that probability must range between 0 and 1. So that probability can never be more than 100% of probability, cannot be a negative. Probability of an event happening is simply the number of events A over the sample space that we have. So for instance, we have a basket, and in this basket, we have 7 apples and 3 bananas. So the probability of picking an apple is 7 out of the total fruits, which is 10. 70% is the probability. The probability of picking a banana is 3 out of the total that we have, which is 0.3. The opposite is called a complement. So what is probability of not picking a banana is this 1 out of probability of picking the banana itself. So if the banana has a 30% chance of being picked, so meaning the probability of not picking a banana is 70%, So this is what we call the rule of complements. So in this case, if our A is 20%, meaning the A complement should be what? 80%. Are we together so far? Any questions before I proceed?
Go through the complement, the last one.
The last one is simply a complement. If, for instance, probability of A is 70%, what's the complement of A? It's 1 minus probability of A itself. So since A is 70%, the complement of A is 30%. Complement is what you don't have. All right? If you are saying you have 20% knowledge on QM, meaning you don't have 80%, complement is what you don't have. Is that clear?
Yeah.
Then we also have probability of the union set. A union B. Simply the probability of A plus the probability of B minus the intersection. A intersection B. If our A was so to start with, we need to know that union means what? Addition. The word which comes in union is OR. Intersection looks like this. It means multiplication. The word which we have is AND. So if we're being given A and B, so to find the intersection for A and B, we'll multiply. Okay, so what is for disjoint events A intersection B means we're going to multiply the probability of A times the probability of what? B. So what is the probability of A? 0.7. What is the probability of B? 0.3. So A and B is 0.21. So what is the union set for A and B? It's the probability of A plus the probability of B minus the intersection. So since our A is 0.7, our B is 0.3, the intersection is 0.21. So when you calculate that, you get 0.79 as a union set. So to unite is to add. If you have two probabilities, A and B, so to find the intersection, if you're both taking two courses and you're sharing QM, so it is the probability of A plus probability of B minus a QM, since you repeat it in there. So the complement, the union set of A and B is what? Probability of A plus probability of B minus the intersection. You must also understand that there's what we call conditional probability. Conditional probability is a pattern which simply says A given B, you put the B down there, and you intersect A and B. So you're going to have A intersection B. Similarly, if you had B given A, which guy will go down? The probability of A. So the bottom guy will go down. This A will come here. Then you intersect the letters A intersection B. Of course, you can put B intersection A and intersection B. It's the same thing. Obviously, we like starting with the letter that comes first in the alphabet, but it's the same. It's the same as 2 times 3 is the same as 3 times 2, except that division now changes. 2 divided by 3 is not the same as 3 divided by 2. So it's very important that this guy always goes down. This guy goes down. Then we have two conditions.
Fallings on the last one. Fallings on the last one.
Oh, thank you.
I've seen that.
A must come down, the B must come down. So the only one paying attention, the rest didn't notice it. I did that on purpose. Okay. So conditions, we have two conditions. A intersection B, if it's 0, it means the events are what? Mutually exclusive. To be mutually exclusive means to have nothing in common. So if intersection of A and B is 0, it means that they are mutually what? Exclusive. What events could be mutually exclusive? Gender, male and female. You can't be male and female at the same time. If A intersection B is the same as multiplying the events independently, probability of A times probability of B. And these two events are what? Independent. This is what we call independence. Or alternatively, if A given B is equal to the top guy, A, regardless of what letter you have on below, it doesn't change the top guy. Or probability of B given A still remains the top guy, B. Means that the events are what? Independent. So these are the critical conditions. So that being said, let me give you examples. Now, as I'm giving you this example, I need to tell you that the conditional probability precedes the basic probability. What do I mean? This is what I mean.
Collins, let me just take down some notes from the previous page.
I'll give you the recording though.
Okay, all right, okay, thanks.
So if we're given data which is showing like this, and you're asked to find the probability of A intersection B, don't multiply these two because there's existence of conditional probability. The first thing is you need to expand this conditional probability. A given B, what did I say? B goes down there, and on top we intersect A and B. So what is A given B? We're given as 0.3. What is A intersection B? We don't know. What is the probability of B? Probability of B is 0.5. So when you cross multiply, we're going to have A intersection B will be given by 0.3 times 0.5, which is 0.15. So if you multiply these two, you'll get it wrong because you're using the basic rule. That rule is superseded when we have this guy. In fact, if I'm going to give you a shortcut, if you're A given B, multiply it with E Banshee, you get a shortcut. You get the intersection always. So what is A given B? 0.3. And what is our B? 0.5. Are we getting the same 0.15? Yes. Now, suppose we're given B given A. What would you multiply it by to get the intersection? The bottom guy. So in short, not B, but the bottom guy, which is A. Finger fair parana, we are usually getting the intersection. So if we had X given Y, what do I multiply by to get the intersection of X intersection Y? Probability of Y. As long as these two are kissing, then you're getting the intersection. So we've only calculated the intersection 0.15. How about the union set? The union set is the most faithful formula because it doesn't change. It's probability of A, probability of...
Collins.
Yes, please.
Maybe I just missed. So the probability of A given B in simple terms, what does it mean?
Probability of A given B is simply the probability of A after B has already happened. It's a conditional probability, even in biblical terms, to say you only get to heaven after you'd have what? Been saved, or after you. It's a condition for which an event will occur. A should occur after B. A precedes B.
So meaning B
has
cannot
read
occur.
now A. I'll explain that you understand it later on more. So,
Okay. All right.
so probability of A is 0.4, probability of B is 0.5, and we found the intersection as 0.15. So here it's 0.4, 0.5, and 0.15. So what we get when we calculate that? .85. That is how we find the probability. Now suppose they ask us to find the opposite, probability of B given A.
0.75, not 85. 75.
So probability of B given A, who wants to expand it for us?
I can try.
Mm-hmm.
Okay, so the probability of A will be at the bottom.
Mm-hmm.
And on top we'll have the probability of A intersection B.
Excellent. And what is the probability of A intersection B? 0.15. This one here. Probability of A, 0.4. So 0.15 divided by 0.4, does it give us? 0.375. Question, are they mutually exclusive? What is the condition for mutually exclusive? Events are mutually exclusive if and only if the intersection is what? Is 0. But the intersection was not 0, it was in fact 0.15. So events are not mutually exclusive. Are they independent? Probability of B given A must be equal to what? The top guy. A. Probability of B. So let's compare. Probability of B was 0.75. Probability of B given A, we calculate as 0.375. The probability of A of B is 0.4. Are they the same? They're neither the same. So we can say these are not what? Independent. I repeat, they'll ask you, are these events independent or mutually exclusive? So we need to go back to our conditions. I said to be mutually exclusive, you have nothing in common. Your answer for the intersection must be 0. But here, our answer for intersection is 0.15. Is this the same as 0? No. Therefore, it is not independent. How about for independent? This is for mutually exclusive, not mutually exclusive. How about for independence? There are 2 rules I gave you. If you multiply A and B separately, they should give you the intersection. So if I multiply 0.4 times 0.5, it should give you 0.15. But I'm getting 0.2 when I multiply these two. It's not the same as 0.15. So they're not independent. Alternatively, I said B given A must be equal to B. So B given A, we've calculated as 0.375, and our B is 0.5. These are still not the same, so we can conclude that they are not independent. So sometimes we can use what we call contingency tables, where we're given A, B, X, and Y. We're given figures 2, 4, 6, and 8. The first thing is you get the totals. What's the total here? 8. Total here, 4. What's the total here? 6. Total here, 14. What's the total of totals? 20. So, to find the probability of A in the axiom I told you, is the number of A elements over the total sample space. And our total sample space in this case is the total of totals, which is 20. This is our sample space. So the total for A here is 6. 6 out of 20, what do we get? 0.3. How about B? The total for B is what? 8. 8 out of 20, 0.4. Who wants to help us? What is the probability of X and what's the probability of Y? The ladies X, the gents Y. Quickly.
Probability of Y would be 12 over 20.
Over 20. For X or for Y?
That for Y. For Y. Y.
Do you agree, gents? 12 over 20? For X?
14 over 20.
Okay. Right, so the intersection of A and B, where they meet, A and B, we draw a plus. They meet at what? At 2. Then over the grand total, over 20, is 0.1. So tell me, what is X intersection Y?
8 over 20.
They meet at 8 over 20, correct. 0.4. So now, can somebody give me the ladies A union B and the gents X union Y? I already gave you the formulas. Ladies, what is the formula for A union B?
That's A plus A plus B minus A intersection B.
That's A intersection B. So give me the parameters for A and B and intersection.
Plus 0.4 plus 0 or minus 0.1.
The gents?
The same probability of X plus probability of Y minus probability of X intersection Y is equal to 0.7 plus 0.6 minus 0.4.
What's the final answer?
The same?
What's the final answer? What's the final answer?
0.9. 0.9.
All right, that's great. Okay, so now let's go to the conditional probabilities. So I'm going to teach you a shortcut for the conditional probabilities. A given B. I'll teach you the normal way. Who wants to try A given B? What's the normal way? A intersection B over what?
Probability of B.
Good. So what was our A intersection B? 0.1. And what is the probability of B?
0.4.
We'll get 0.25. Or the shortcut is, where do they meet A and B? They meet at 2, right? But the total for the bottom guy, the total for B, what's the total for B? 8.
8.
So 2 over 8 is got what? 0.25 is the same thing. Suppose I ask you to find the reciprocal B given A. They still meet at 2, but now the total for which data? The total for A, which is
for A, 6.
So 0.33. Even if you use Bayes' theorem, this is called Bayes' theorem, we still get the same answer for B given A. All right. This is the toughest in this course. If you understand this, then you're good to go. If you're sure, all right. So, how do we find X given Y? How do we expand this? A bit of what? X intersection Y over what? Bottom guy Y. So what was our X intersection Y? 0.4 and our Y is 0.6. So 0.4 over 0.6 is 0.67. Or where they meet, X and Y, they meet at 8. So you go to 8 there. But the total for the bottom guy, the total for the Y. What is the total for Y? We go here, the total for Y is what? 12. So when you divide this, you still get the 0.67. It's the same thing. Okay, so here Y given X, the same thing, but the total for the bottom guy, this guy, the bottom is 14, the X is 14. So I put 14. So once you get what I've taught you precisely, it becomes very easy to look at the complex questions. Let's go to the test questions now. A survey was conducted, all right, to get information of students and their income levels. So we have public, private, middle, low, and high. The totals have been done for you already. So please, this is our last question. So everyone is supposed to answer a question either about more than 10 questions. So please pick the easier ones as quickly as can be. So what's the probability of the student coming from the middle income family? What do we do? Anyone quickly? Middle income, how do we find it?
It's 35 over 100. Oh, 35 over 235.
The probability for middle, we get the total for middle, which is 100 over the sample space. So simply 100 over 235. So what is the probability if the student comes from the middle income? Find the probability that they attend private. So if means slash. So probability if middle. So after middle has happened, what's the probability that they came from private? So we call private PV and public PB. So PV given M. So where they meet PV and M is what? 35. So we put 35. But the total for which guy? The bottom guy, which is M. Our M is what? 100.
100.
All right. So this is 35 over 100. I've started the first two for you. Now let's continue. Part 4, find the probability that the student attends private university and comes from middle. What are they looking for?
They're looking for intersection.
Excellent. Because of the word what? And. So what is the notation? Private intersection what? Middle. Continue. Then, where do you go? Where do you go? Where private meets what? Where private middle, yes, but the total
that's 35.
but the total for the total for
The
what?
sample space.
Sample space,
Sample
good.
space.
It's total for everything, yes. All right. So they still meet where? They still meet at 35, right? But the total for the sample space, which is what? 235, which is why this answer is correct. Are these events coming from law and public universities independent? So what do we do? How do we know they're independent? How do you know they're independent?
Probability.
Is it me breaking or it's
I think it's him.
anyone else? There are two methods that I gave you. What is the denotation? Come on. Okay, because this question is coming in your test on Friday. So I assume you already know. We can end here since we were not participating. All right. So I have labored to explain the axioms of probability. I've also labored hard to teach you descriptive statistics and also how to tell this is a mutually exclusive event. So questions don't go outside what I've just explained. The principles just be alternated, and I'll later on teach you how to do the tree diagrams and experimental probability, so that you could as well be able to differentiate. So thank you so much for your time. Have a good evening.